Good day, learners! Welcome to Now You Got It! In this video, you will learn about arrays and linked lists in Python. Arrays and linked lists are both structures that can hold data, and the type of data they hold is defined by the programmer. But the question is, what's the difference between the two of them? Let's find out. Let's start with arrays. What are arrays? It is the most basic structure for storing and accessing a collection of data. It is used to put or arrange things in particular order so that it is nice to look and well arranged. Now let's learn its types. One-dimensional array. It is composed of multiple sequential elements stored in contiguous bytes of memory and allows for random access to the individual elements. As for example, please look at the picture at the screen. Individual elements within the array can be accessed directly by specifying an integer subscript or index value, which indicates an offset from the start of the array. Programming languages typically use square brackets following the array name to specify the subscript x with the subscript of I. This is similar to the mathematics notation xi, which allows for multiple variables of the same name. A one-dimensional array is a collection of contiguous elements in which individual elements are identified by a unique integer subscript starting with 0. Once an array is created, its size cannot be changed. Here are methods of one-dimensional arrays that can be used in Python. Array creates a one-dimensional array consisting of size elements with each element initially set to none. Size must be greater than 0. Length returns the length or number of elements in the array. Getitem returns the value stored in the array at element position index. The index argument must be within the valid range, accessed using the subscript operator. Setitem modifies the contents of the array element at position index to contain value. The index must be within the valid range, accessed using the subscript operator. Clearing clears the array by setting every element to value. Iterator creates and returns an iterator that can be used to traverse the elements of the array. One real-life example of one-dimensional array is arranging the grades of a CPE student from highest grade to lowest. For other applications, two-dimensional arrays or grids are more useful. These grids are assumed to be rectangular and are of fixed dimensions. It also consists of a collection of elements organized into rows and columns. Where the mathematician might say AI, J in Python, we can say A with the subscript of I, J. In Python, we want the row I from table A and column J from that row. A table is a sequence of rows. Each row is a sequence of individual cells. This allows us to use mathematical-like notation. One real-life example is organizing the grades of a student in a report card per quarter. There are also situations that demand multidimensional arrays or matrices. A matrix is a collection of scalar values arranged in rows and columns as a rectangular grid of a fixed size. In mathematics, a matrix is an m by n rectangular grid or table of numerical values divided into m rows and n columns. One real-life example is there are many balls in a box with different colors. Then, you need to arrange it by their color. Kindly look at the sample picture at the screen. Next one is jagged array. It is an array whose elements are arrays. Unlike multidimensional or two-dimensional arrays, the elements of a jagged array can be of different dimensions and sizes. Please see the sample picture. Now we're done with arrays, let's talk about linked lists. What are linked lists? The linked list data structure is a general-purpose structure that can be used to store a collection in linear order. It improves on the construction and management of an array and Python list by requiring smaller memory allocations and no element shift for insertion and deletion. A linked structure contains a collection of objects called nodes, each of which contains data and at least one reference or link to another node. The nodes are connected in sequence to form a linear list. The last node in the list, commonly called the tail node, is indicated by a null link reference. The first node in the list, however, must be named or referenced by an external variable as it provides an entry point into the linked list. This variable is commonly known as the head pointer or head reference. Please see the example at the screen.